canine science teacher. I'm here to help you be a Sci fanatic. Our topic for today is about percentage composition of compounds. Take note, class, that this will be our last lesson for the second quarter. The learning objectives for today are the following. Determine the percentage composition of each element in a given compound. Differentiate empirical from molecular formula. Calculate for the empirical formula of a compound given its percentage composition. And calculate for the molecular formula of a compound given its percentage composition. Let's have a quick recall of our last lesson. So I want you to fill up the blanks in our concept map, and I want you to choose on the following listed in our notebook. So let's start. Matter is made up of, you can pause the video while you are thinking, class. The answer is particles, which may be atoms, ions, and molecules, whose amount may be expressed in terms of mole, which is equal to, or whose mass is expressed in grams per mole and equal to the Avogadro's number. I hope this is very clear to you guys. So we will proceed to our next lesson. In chemistry, scientists use percentage composition to give the percent by mass of each element in the compound. So this is the formula that we'll be using. Percent of the element is equal to mass of the element divided by the total mass of the compound times 100%. Sodium nitrate is a common preservative used in cured meat products, including bacon, deli meat, and jerky. It has been linked to the development of heart disease and diabetes. This additive has been cut out from some foods due to these concerns. Looks yummy, isn't it? Reminder, class, take these foods in minimal amounts. Let's consume a better alternative. Now let's calculate the percentage composition of sodium nitrate, or NaNO3. But before that, I want you to grab your periodic table of elements, your calculator, your pen and paper, and bring with you a lot of patience. Using the percent composition formula, mass of each element in 1 mole divided by the molar mass of a compound times 100%. So let's proceed to step 1. First is to find the molar mass of sodium nitrate. First, list down all the elements and then take note of the number of atoms. For sodium, that's only 1. Nitrogen, also 1. And oxygen is 3. Then, multiply it by the atomic mass found in your periodic table. Next, get the product and then get the sum of all the products. So, the molar mass of sodium nitrate is 85 grams per mole. For step number 2, determine the percent composition of each element in the compound. To get the percentages of each element, just follow the formula. So divide the mass of the element by the molar mass of the compound and multiply it by 100%. Then you will get the following percentages. Check your answer by adding up all the percentages of all the elements. The sum should be 100% or close to 100%. Let's have another example. Calculate the percentage composition of water. Using the formula, percent of each element divided by molar mass times 100%. Again, let's go to step 1. We should find the molar mass of the water. So we should identify the number of atoms of each element, then multiply it by its atomic mass, get the sum, and the molar mass is 18.02 grams of water. Step 2 is to determine the percent composition of each element in the compound. So following the formula, mass of each element divided by the molar mass times 100% will give you 11.21% for hydrogen and 88.79% of oxygen. Again, in checking your final answer, sum up all the percentages and it should be near or 100%. Let's have this activity. Finding percentage composition. I want you to solve the problem scientifically by showing the complete solution. Write your answer on a separate sheet of paper. Question number 1. Facial cream used to treat acne has a component of benzoyl peroxide, C14H10O4. What is its percentage composition? You can pause the video while doing this task. To answer the first question, first step is to find the formula mass. First thing is to list down all the elements present in the compound. We have carbon, hydrogen, and oxygen. Then, get the number of atoms in each element and its atomic masses. Multiply the number of atoms and its atomic masses, and then sum it up until you get the formula mass. So the formula mass of benzoyl peroxide is 242.2 AMU. For the second step is to list down all the percentages of the different elements. List down the atomic masses divided by the total formula mass of the compound. Multiply it by 100%. And then these are the percentages of each element. To check whether your answer is correct, the sum should be near or should be equal to 100%. For our second question, glucose or blood sugar, C6H12O6, is a 6-carbon sugar. It serves as an energy source that fuels our bodies. What number percentage of carbon is present in glucose? To answer question number 2, again, you need to list down all the elements present. Take note of the number of atoms per element and its atomic masses. Multiply, then sum it up, and the formula mass of glucose is 180.18 AMU. For step 2, we need to find the percentage composition of carbon. So 76.06 is the atomic mass of carbon and 180.18 AMU is the formula mass. You need to multiply it by 100 and the answer will be 39.99%. Now let's go to empirical and molecular formulas. An empirical formula shows the simplest formula of a compound. Also, it shows the number of atoms of each element in a compound in the most simplified form using whole numbers. Remember, class, that it does not indicate the actual number of atoms in the molecule of a compound. While molecular formula of a compound gives the relative or the exact number of atoms and the type of atoms present in a molecule of a compound. So let's compare the formulas of glucose in its empirical form and molecular form. In the empirical form, we can see here that it is the simplest form of formula. While in molecular formula, it gives you the exact number of atoms present in the compound. Now let's determine the empirical and molecular formula from percentage composition. So the sample problem is, determine the empirical and molecular formula of a compound having a molar mass of 294 grams per mole, and the following percentage composition: 26.53% for potassium, 35.37% for chromium, and 38.10% of oxygen. First step is to convert the percentage composition to an actual mass in grams. So the percentages will become grams. After converting to the actual mass in grams, convert mass to moles of each element by dividing its atomic mass by its molar mass given by the formula. Again, to get the value of N, atomic mass divided by molar mass. So, to get the N of the following elements, you follow the formula and then you will get now the mole equivalent. Take note that you should find the smallest mole value, which is 0.680256 mole. Next step is to find the whole number ratio of the moles of the different elements by dividing the moles of the elements present by the smallest number of moles. So after dividing, we can see here that the only decimal part in the number of atoms is 0.50. So to convert this decimal part to a positive integer, we use a multiplier, which is number 2. So 1 times 2 is 2, and 3.50 times 2 is 7. So now we can see that they are now in their whole number form. So the empirical formula is K2 Cr2O7. After getting the empirical formula, we are now ready to get the molecular formula of the compound. So to get the molecular mass, compute for the molar mass of the empirical formula. Remember that we have the K2Cr2O7. We need to get the molar mass of this compound. So the empirical molar mass is 294 grams per mole. Next is to divide the actual molar mass by the empirical molar mass. Remember in our given that it says there that the actual molar mass is 294 grams per mole, and our empirical molar mass is also 294 grams per mole. So we cancel out common units, so the answer is 1. This 1 will be the ratio that we will use to get the molecular formula. We will multiply 1 on the subscript in our empirical formula. So 2 times 1 is 2. For chromium, 2 times 1 is 2. For oxygen, 7 times 1 is 7. So the molecular formula is K2Cr2O7. I know you're all excited in solving for empirical and molecular formulas, but these activities will be given in the next video lesson. I know that our lesson is difficult, but remember, all things are difficult before they become easy. So class, have patience in doing our task. Bye! Thanks for watching. I hope you had a fantastic day.